Hey everybody, it's day 8. We're carrying off with surface area of a cone. Just a couple definitions to redefine. A cone is a solid figure with one circular base and a vertex that's not on that base. So if you look at the picture, you see the vertex comes to a point, and the base is obviously a circle, and the area and the formula that we're going to use for that is just this right here. Pi r squared. And we've already been doing that, so it should be previous knowledge and some retained knowledge that we have used numerous times before. Our slant height is on that lateral face, so that side. So that slant height is what we're going to be using to figure out what our lateral area is. And our true height, or when we talk about height, is that height from the vertex to the center of that base. So when we talk about lateral area, that is the area that the formula we're going to use is going to be pi times our radius times the slant height. So that formula that we're going to use is that lateral area plus the surface area of our circle of the base. So when it comes down to it, our surface area is pi r L plus pi r squared. And pi r squared is just our area of the base. So hopefully if you're in Mr. Naughton's class, he'll give you a formula sheet. If you have any other teacher, they should give you a formula sheet that has this all together and makes life a little bit easier for you. And I know this is kind of tough, keeping track of what do I use, when do I divide by 3, but it becomes pretty easy once you get the numbers. It's just a plug and chug. It turns into algebra. But for some of you, mathematronics is hard for you anyway. So let's just rock and roll and go from there. So let's find our base. So our pi r squared. And our pi r squared for this first problem is going to be pi times our radius, which is 5. And we're going to square that. So if you plug that in, 5 squared is 25. So if you get 25 pi and you plug that in, you should end up with 78, and we'll round 78.54. So you end up with 78.54. And we'll say, okay, that's our base. Now, if we end up plugging in and getting our lateral area, so we got pi times our radius, which is 5, and our lateral face is 13. And if you plug that in, you should end up with 2, and we're going to round it. So we're going to say 204.204. And if you don't like my handwriting, deal with it, because I am not very good at, I scrabble all over the place. And if you're in my class, you know exactly what I'm talking about. So if we add those two together and we say, okay, we got our lateral area and our base. So we got 78.54 plus 204.204. And if you add that together, you should get 282.74. And we're talking in millimeters. And again, we're talking area, so it's squared. Volume, we were talking cubed. But in area, we're talking squared. So we got 282.74 millimeters squared. All right, pretty simple, straightforward, right? So let's go to number 2. So our lateral area, well, where is our face? Our face is this right here. They don't give us our face. They give us our height, and they give us the diameter, and our diameter is 12. So we know half of our diameter, our radius, is going to equal half of that. So our radius is going to be 6. So first off, we need to figure out what our slant height is. In order to find our slant height, we need to use Good old Pythagorean Theorem. So we have our height, we have our diameter or our radius. So all we're going to do is plug that in. Since this is a right angle, that is our hypotenuse. So we're going to put c squared as the equal sign. So we're going to say 8 squared plus 6 squared equals our hypotenuse, which is c squared, or our slant height. So 8 times 8 gives you 64, plus 6 times 6, which is 36. Well, this works out to be pretty nice because we get a perfect square. That's 100. C squared, if we square that, well, 100 is a perfect square of 10. So our slant height ends up equaling 10. So now we can rock and roll and plug this in. So we have pi times our radius, which we said was 6, times our slant height, which is 10. And you plug that in, that's 60 pi, and 60 pi gives you 188.5. So now we got that piece of the puzzle. So our base, or the area of our base, we're going to end up finding out is pi. Oh, sorry, let me delete that. We end up getting pi times our radius, which is 6, squared. So we end up with 36 pi, which ends up being 36 pi. I plug that in. Where's your calculator? Let me get it. 36 pi, give me a second here. 113, we'll say 113.1. So once you have that, you plug it into your lateral area, which is 188.5 plus 188.5. So if you plug that in, plus 188.5, and you end up with, we'll say 301.6. 301.6 feet squared. And that is your surface area for that cone. And again, I move all over the place, so I apologize if you're watching this on the video and I talk fast. So you might have to pause this as you're watching me do this. So if you're ambitious enough and you've kind of seen this, number 3 is pretty easy and straightforward. If you want to try that, go ahead and do it now. And pause the video and knock it out. Now, if you pause it and tried it, you'd find out, okay, well, we need to find the surface area, the hypotenuse of this, which is our slant height. So we need to find that. So just like the last problem, we ended up saying, okay, we have 5 squared plus 12 squared equals your slant height, which is c squared. So once we get that, 5 times 5 we know is 25. 12 times 12 we know is 144 equals c squared. Well, if you add that together and square root it, well, let's see. 144 plus 25, that gives you 169. Well, if you know your square roots, you know that that is a perfect square of 13. So now you end up having your slant height of 13 up here. So we got that piece of the puzzle. Now if we plug and chug, do the rest of this. Okay, so we got our surface area, our lateral area, what we're going to say. So our lateral area equals pi times our radius times our slant height. So that ends up being pi. Our radius is 5. Our slant height is 13. And if you plug that in, you get 65 pi, or you end up with 204.204 again. So there's your lateral area. now we need to find our base. And we know that our base is going to be pi radius squared. So if we end up with pi, radius is 5 squared, we end up with pi times 25, or 25 pi, which is equal to 78.54. So now we got the two pieces of the puzzle. Now it becomes plug and chug. So you end up with, let's make this a little thicker. So you end up with lateral area plus your base. So your lateral area, we said, was 204.204 plus 78.54. And if you add that together, you should get 282.74, and we're talking in units of centimeters squared. And that would be your surface area for that cone. Again, I'm not the neatest writer. I know I'm not like Mr. Naughton or Roby or Ross or Hendrickson. So deal with it. Anyway, I got my wife over here laughing at me. So she's grading papers right now as well. She's a math teacher at Douglas High. So let me erase this and let's do number 4. All right, take this away up here. So now what we have here, they're giving us our slant height. They're giving us our true height, but we don't have our our radius. So in order to find that, again, Pythagorean. And remember that this 8 inches squared needs to end up being the equal. So if we say, okay, 5 squared plus, well, it's our radius, so let's just say r squared equals 8 squared. All right, so we're good there. So 5 times 5, we got 25 plus r squared, 8 times 8 gives you 64. Okay, and if you end up subtracting that, you end up with 39. So you end up with r squared equals 39. Let me double check that. So 64 minus 25, that gives you 39, right? And so if you root those and you figure out, okay, well, if we try to break down 39, you got 3 and then you have 13. Well, that doesn't break down to anything else. So you end up with the square root of 39. So your radius ends up being the square root of 39. So we're going to leave it as that and go from there. Okay, so you can say the square root of 39, if you plug that in your calculator, it ends up being 6. Let's do that real quick. Hang on a second. Square root of 39 equals 6.244. So we'll say equals 6.245. All right, well, we're going to keep it square root of 39. So our surface area is going to end up being pi times the square root of 39. I leave it like that because it's more accurate. Times our slant height, which is 8. And if you end up plugging that in, you get, so we'll say 8 pi 39, we'll say 8 square root of 39 pi. So if you plug that in, you say, okay, 8 times the square root of 39 times pi, and that gives you 156.95. So you end up 156.95. So there's your, I said surface area, I meant lateral area. So you get 156.95. And now you want to add that to your base, and your base is going to end up being pi times radius squared. So if you say pi times the radius squared, well, the square root just ixnays this, so your base ends up being pi 39 or 39 pi. And if you end up doing that, you get 122. Let me double check that. So you get 39 pi 122.5. Yeah, we'll call it plus 122 point, say 522. 522. And if you add that together, your final answer ends up being 279.47 inches squared. And I'll zoom out a little bit so you guys can kind of re-see that. This is from the previous problem. So again, we had to use some Pythagorean. We left it as radical 39, plugged it in, find our lateral area, found our base, added them together, and that's what we came up with. Capiche? Like I said, you could always just pause this as we go. All right, so this problem was fun. I did this the other night and had a good time with it. So if there's one thing I've noticed from my 6th and 7th period, you guys have kind of forgotten distributed property and how to do this. So this is always great practice. So again, your surface area is going to equal pi times your radius times that slant height plus your base of that circle, which is pi r squared. Okay, so let's rock and roll from here. So if we take pi times our radius, which is x, x minus 2, times our slant height, which is x plus 7. And we're going to add that to pi, radius x minus 2 squared. So you might want to write a little small on this, because I'm going to erase. I write all over the place. Okay? So let's rock and roll with this bad boy first. Do you remember FOIL? That is what we're doing here. We're going first, inner, or first, outer, inner, last. So for this first lateral area, if we said first, x times x gives me x squared. Outer, x times 7 gives me 7x. Inner, negative 2 times x gives me negative 2x. Last, negative 2 times 7 gives me negative 14. And I just realized that when I did this on my paper, I said plus 2 and not minus 2, but that's okay. All right, so you end up with that. All right, and remember, you still have pi on it right there. All right, now let's deal with our area of our circle. So if we expand that out, I'm going to do it up top here. So we're x minus 2 times x minus 2. Again, first, outer, inner, last. X times x, x squared. X times negative 2 minus 2x. Inner, negative 2 times x minus 2x. Negative 2 times negative 2 gives me positive 4. So if we were to combine that, we got x squared minus 4x plus 4. So the only things we can combine is that minus 2x minus 2x. So we end up with that puppy right there. That's not a good color to use. You got to use a lighter one there. Let me see. Let's use that guy. So we end up with that right there, okay? Now, let's go back. I didn't combine this. So you end up over here with x squared. 7x minus 2x gives you plus 5x minus 14. And again, this is all pi, and we haven't done nothing with the pi up here. So there's still pi to this. If me going back and forth confuses you, I apologize. I don't have much space to write on here. All right, so now what we end up having is x squared plus 5x minus 14 pi plus x squared minus 4x plus 4 pi. All right? So, again, now it becomes distributive property. So, I'm erasing this because I have no more space. I'm going to have to probably re-record this, but it's okay.
No, you're doing good. I'm done.
My wife is giving me encouragement. All right, so now, if you were to end up distributing to this, to that, and to that, so you get x squared pi plus 5x pi minus 14 pi. Again, distribute, distribute, distribute. So you got all that plus x squared pi minus 4x pi plus 4 pi. If I'm losing you, I'm sorry. But it's all just distributive property. So let me get rid of this. Okay, now all it becomes is that the parentheses are sort of redundant, so we could drop those. And it's combining of like terms now. So you got x squared pi, x squared pi. So if we put those together, x squared pi, x squared pi plus x squared pi, you get 2x squared pi. Those are gone. Now we have negative 4x pi and 5x pi. So what you end up with is just plus x pi. Those are gone. And then you're left with negative 14 pi plus 4 pi gives you minus 10 pi. If that was a pain in the butt, I know, because it was a pain in the butt for me. But it is combining of like terms and making sure you know how to distribute. And that is the expression that you would write for the surface area. Again, you might have to rewind and go back because I didn't have enough space to write, but you guys will be all right. Okay, last problem. We're almost there. So we have a cone that has a surface area. So we have a surface area of 77 pi. And then what is the radius of the cone if the slant height is 4 millimeters squared? Okay, so let's set this up. So if we have pi, we're looking for the radius. The slant height is 4. So we got pi times the radius times 4 plus pi times the radius squared, and it all equals 77 pi. Now we're just solving for r. So if we put these together, and if you guys remembered standard form, that is the easiest way to do this. So if we took this and set this equal to 0 and put the 77 pi over this way to the left side and rewrote it as pi r squared, and you put together plus 4 pi r minus 77 pi, equal it to 0, you could factor this thing out. You guys with me? And here's the other thing. You could pull out a common factor of pi, and pi. So rewritten out again, it would be pi taken out. You got r squared plus 4r minus 77 equals 0. So remember factoring. And again, I'm running out of space here, so I'm writing all over the place. But if you make your x method and you say, okay, a times c. Well, a is 1. C is negative 77. So if you have a times c, you get negative 77. Your b is 4. Well, what two numbers can you come up with that multiply to negative 77 but add to 4? Well, your immediate thought should be like, well, okay, we could have 11 and we could have 7. But what has to be positive? What has to be negative? Well, 11 times 7 gives you 77. But if we said 11 times negative 7 gives you negative 77 when multiplied, added gives you 4. Now we could rewrite this out as pi. And we'll use r as a variable. So we say r minus 7 times r plus 11 equals 0. Well, here's the deal. If you set this equal to 0, r minus 7 equals 0, and then r plus 11 equals 0. So therefore, r equals negative 11. And r equals 7. But here's the deal. Your radius can't be a negative number. So your radius has to be positive. So if they're asking for what is your radius, well, your radius equals 7. And that is your answer. Was that long-winded? Absolutely. Was that a hard problem? Yes. Will that be in your final? I hope not. But anyways, if you have any questions, ask your teachers. I hope that wasn't too painful, but there you go. You got surface area of a cone and writing things out as an expression. Those last two problems were in-depth, and those were tough. So I hope you guys kind of understood that. If you have any problems, pause the video, go back, rewind it. I talk fast and write all over the place. So I hope you understood that. And hey, 15 days left. Let's rock and roll. Later.